Hi guys, today we are going to talk about UDP. So what is UDP? It is User Datagram Protocol. In computer networking, the User Datagram Protocol is one of the core communication protocols of the Internet Protocol Suite used to send messages transported as datagrams in packets to other hosts on an Internet Protocol network. Within an IP network, UDP does not require prior communication to set up communication channels or data paths. So you may ask, what is the difference between UDP and TCP? So here in Wiki, there is an explanation. Over here, if you take a look at this section, you can see the pros and cons of UDP. But what makes UDP a good choice for IoT communication? There are three reasons. First, it is lightweight. Second, it can broadcast. Okay, and third, it can multicast. These are the Python codes for UDP send and UDP receive. The UDP send is placed in the IoT device, and the UDP receive is placed in the IoT server, that is the platform where you have the backend and the dashboard. Okay. First you have to declare the destination address, IP address, which is the server's address. Okay, and next you have to put in the port number. Alright, and next is the message. Okay, you can imagine that this is your temperature sensor message. Okay, but after that, when you declare this as a string, right, you have to convert it to bytes. Okay, because when you send, you need to send in bytes. Okay, so before you do the sending, you have to declare this line. This is the most important. Alright, so you use this socket API to create a socket object that is working with the IPv4 address family. Okay, so AFINet means IPv4, and sockdgram means it is using UDP. Okay, so this is UDP, so this means UDP, and this means IPv4 addresses. Okay, so this is the object, and you use the object to send the message to this destination through the port number. This is the receiver code. There is a particular line that is required here, the sock bind. This means that you are binding your own IP address to this port number so that you are able to receive data. This line receives the data. This is the buffer size, which you can estimate from the data or the amount of data which you are expecting. Now I'll do a small demonstration of the two sets of codes here. This is the receiver on the server. This is the sender, which is run from my own Windows PC. Okay, so now let's run the receiver. It's waiting for messages to come in now. And over here, I will run the sender. You can see this is the message that is received. Okay, and this is the IP address of the sender. Right? Okay. Okay, so if you need security for UDP, you need to use DTLS, right? And as you know, TCP has TLS as its security, and in the same fashion, UDP also has its secured version called DTLS. Right, it says here DTLS stands for Datagram Transport Layer Security and is a communications protocol designed to protect data privacy and prevent eavesdropping, tampering. Right, it does this by doing some encryption. Okay, so now let's go to a demo. Now let's run DTLS on the server. This is the command. You are now waiting for the whatever transmission to come in. Okay, here is the client. So this is the IP address of the server, which is this one. Okay, and this is the port number 443. Okay, 443, and let's run this. Right, so you can see that it has a successful connection, and here at the client it will tell you the SSL session is DTLS version 1.2. Okay, the cipher, the session ID. Let's try to send messages between each other. So now I'm the client, I want to send something over to the server, so I put a hi. Yeah, so you can see it appears here, and the server now wants to send something over to the client. Hi back. Okay, so it's working. Just now you have seen the workings of DTLS. So now I want to show you the workings of TLS. Okay, so this is TCP/IP version. Okay, let's run this. Okay, before we run this command, we have to change this parameter from DTLS 1.2 to TLS 1.3. This represents TLS 1.3. And likewise, on the client side, you have to change from DTLS 1.2 to TLS 1.3. Okay. Now I will run the server side. This is now accepting data, and now I will run the client side. Good, the connection is successful. Okay, so now we can see that the protocol is 1.3. Okay, so this is the cipher, this is the session. So now let's try to send something from the client to the server. It appears here, and now let's try to send something back from the server to the client. This is here. Okay, so we have come to the end of the video. I would like to recommend you this site, which you can download the DTLS client and DTLS server C scripts. These two scripts can be useful for you. You can compile them and use them in your Python or whatever applications. The other website I would recommend is this site. Okay, it contains the Python wrapper for the client and the server. So if you click client.py, you can find the TLS and DTLS wrapper inside. Same for the server.py. You can find the wrapper for DTLS and TLS. So this would be very useful for you if you do Python programming or Python apps like Flask or Dash. Okay, and yeah, goodbye and good luck, and hope you enjoy the video.